Okay, we are still talking about radicals, but I know the last few sections have been long for the notes, and this should be a lot quicker. Okay, so for solving radicals, you're going to get the radical all by itself by adding, subtracting, whatever it takes. Then you're going to do the inverse operation. So if it's a square root, you'll square it. If it's a cubed root, you'll cube it on both sides. And then you solve for the variable. So let's look at example 1. So on the radical, there's nothing outside the radical. So that's what I mean by isolate the radical. So we're ready to do the inverse operation. Since this is a square root, we're going to square both sides because that's the opposite. So I also have to square that side. So the square root and the square cancel. So you're just left with whatever's inside. 5 squared is 25. And then you just solve this like normal. To get x by itself, you would subtract 1. So 2x equals 24, and then because those are being multiplied, to get rid of the 2, you're going to divide both sides by 2. So x equals 12. And that's it. So on example 2, it's a little harder. So you've got the 2 that we need to move and the 5. So you're always going to add or subtract first. Okay? So we're going to add 5 to both sides. You're left with 2. The cubed root of x plus 1, those cancel, and 19 plus 5 is 24. So then, since that's being multiplied, to get rid of the 2, we're going to divide by 2. So the cubed root of x plus 1 is equal to 12. But that's how number 1 started. So since that is a cubed root, the opposite is to cube both sides. So cubed root and cubed cancel. You're left with x plus 1. And then this is going to be pretty big. Let me get out my calculator. We've got 12 times 12 times 12, which is 1,728. So now to get x by itself, subtract 1. So 1727. I have no idea how you would do that without any work. That's crazy. So the other idea is if we have rational exponents. You can change this back to radicals, but you don't need to. So you are going to get the exponent term by itself. So like on number 3, it would just be the x to the 1/4. On number 4, it would be the entire group to the 2/3 power. Okay? To get rid of the exponent, you're actually going to take the reciprocal, because if you have 2/3 times 3/2, well, 2 times 3 is 6, 3 times 2 is 6, so 6 over 6 makes everything to the first power. So that's the idea, okay? So on example 3, we're going to get the x to the 1/4 by itself first, because that's step number 1. Remember, you always add or subtract first. So 4x to the 1/4 is equal to 2. That's being multiplied, so to get rid of the 4, we're going to divide. And we can't really divide. If you want a decimal, that's fine, but 2/4 reduces to be 1/2. I like to leave it in fractions. It would not be wrong if you changed it to a decimal though, okay? And then this, you need the reciprocal. So the reciprocal of 1/4 is to raise it to the 4/1 power, which is really just the 4th power, okay? Because then those cancel. So you're left with x to the 1st, you don't have to write the 1, and then 1 times 1 times 1, think of that, over 2 times 2 times 2 times 2. All right, so we get 1 over 4 times 4 is 16. There you go. And there is a decimal that's equivalent to that. Don't round the decimal though, you need to use all the decimal places. That's why I just leave the fractions. On example 4, everything inside is fine because it's to the power, so we're going to subtract 1. So we get 9. I'm going to rewrite this. So we need to take the reciprocal power. So the reciprocal power, let me get rid, oops, is 3/2. Is 3/2. Sorry. I'm going to plug in my tablet. Okay, so then those powers cancel, so we get 3x minus 5. It's just going to stay to the first. And then 9 to the 3 halves, remember the square root, because that's your root, the square root of 9 is 3, and then 3 to the 3rd power is 27. If you're not sure, you can type that into a calculator and it will give you that answer. Add 5 to get x by itself. And then those are being multiplied, so we'll divide by 3. And 32 does not divide by 3, so I just leave it as a fraction. No decimals needed. All right, so now I'm going to let you try and see how you do.